This is 6.6, the law of cosines. Much like the last lesson, there was a law of sines. The law of sines can be used when you have you set up a proportion with the relationship between the sides and the angles. So here, the law of cosines is very similar. So you have all three of these formulas, but really, if you study it, this is really just one formula, just kind of switched around depending on what you're trying to find. So, the way I memorize this, it could be totally different. Let's just focus on this first one. So you have a squared equals b squared plus c squared, and then minus 2bc. So it's the same as this, and this side matches the angle over here. And again, notice the relationship on each one of those. So AC is AC, and then angle B is the side B that you're trying to find. AB, AB, and the angle is the side that you're trying to find. So it's the same relationship when you're trying to memorize those formulas. All right, so the law of sines cannot be used for side angle side. If you go back and look at that video, the notes that we did, side angle side was the ambiguous case that we had to look at. And then, of course, I don't think we looked at a side scenario, but you can't use, if I give you the three sides of a triangle, you can't use the law of sines. The law of sines, remember, you have to have an angle that matches the side, and that's why the law of sines, you set up a proportion. So side, we don't have an angle, all right? And then the same thing with side angle side, we don't have an angle that matches the side. That's why you can't use the law of sines. So we have to use the law of cosines. So let's look at two examples. So here's a scenario. Notice this is side angle side, so you cannot use the law of sines. So we're going to have to use the law of cosines. And notice the only angle I have is angle C. So that means I'm going to literally use C squared equals A squared plus B squared minus 2AB cosine of C. That's the formula I'm going to use. So all we're going to do is just substitute things in and then use some algebra. So we're trying to find side C. So we're going to take A squared, so 212 squared, plus B squared, 388 squared, minus 2 times 212 times 388 cosine of C. And cosine C we actually know, which is 82.4. So notice everything on this side of the equation we actually know. So that's just a matter of plugging that in to get some wonderful big answer. So we're going to get 173730.2367 approximately. And we're going to take the square root. So it's approximately, if we just wanted to do to the nearest, whole number, it's approximately 417 feet, if that's the measurement that we're doing. So, so that's what we would be solving for, is side C. We've got to do that. All right, and then if you wanted to, you can go back and do the entire thing if you wanted to find out angle A, because then once you know angle C and you know side C, which we just now found, then you could, now we have a pair, now we could use the law of sines to try to find angle A or angle B, and then from there you can easily solve the entire triangle. All right, so let's look at one more example. So notice on this one we have side. We notice we have all three sides. We have no angles, which means we cannot use the law of sines. We have to use the law of cosine. So, in this case, they're all three the same. It doesn't make a difference which formula we're going to use. I mean, they're all the same. So I'm just going to do A squared equals B squared plus C squared minus 2BC cosine of A. So we're basically going to find this angle first. Okay, so notice we have everything except for the angle. So we're going to literally just plug things in. So side A is 5, side B is 8, side C is 12, minus 2 times 8 times 12 cosine of A. All right, and then we're going to solve this. So to solve it, you can pause the video and see the math that I did. Again, 8 squared, 12 squared, 5 squared, 2 times 8 times 12 is 192. I added these two together to get 208. I subtracted 208 and got negative 183, and I divided both sides by negative 192. And then once I get down to here, I'm just going to get from here to here, I just take the inverse cosine. So I'm literally doing the inverse cosine of both sides. So I get approximately 18 degrees for angle A. So once I get angle A, and once you did this, I would go back and try to solve for angle B. Although you have a couple of choices, you can do the exact same thing, like literally set up side B. Just do B squared equals A squared plus C squared minus 2AC cosine of angle B. So you could use the law of cosines to find angle B, or you could use the law of sines, because now we have a pair. So we literally could do sine of 18 degrees over 5 is the same as sine of B over 8, and that would give us angle B. I personally, just my recommendation, once I use the law of cosines, I think the law of sines is a lot less work to be involved. So once I use the law of cosines once, I typically just switch over to the law of sines. That's what I normally do. It's just my recommendation. But again, you could do either one, use the law of cosines again, or just switch over to the law of sines to find the angles. And once you find the second angle, then it's very easy just to take 180 minus 18 degrees minus angle B, and that will give us angle C. Okay, so really, I would just use the law of cosines once, the law of sine once, and then you're practically done. So that's a quick summary of using the law of cosines.